Let's jump right into this explainer. Today, we're tackling a brilliant architectural fix for a problem pretty much everyone is faced with modern AI assistants. They basically have the memory of a goldfish when it comes to your reminders. We're going to explore a highly specific, but honestly incredibly clever open-source skill called qqbot-remind-absolute. It's designed for the OpenClaw gateway, and it takes a fundamentally different approach to how bots handle time. It's a total game changer for anyone trying to build a truly reliable personal assistant.
So, let's look at the core problem. Picture this. You're chatting with your AI assistant on your phone, maybe through a messaging app, and you tell it, "Hey, remind me to drink water tomorrow morning at 8 a.m. The AI cheerfully replies, "Sure thing, I've got you covered." But overnight, the server hosting your bot reboots for a quick update, or maybe a process just crashes and restarts. The next morning, 8 a.m. rolls around. Does the bot actually remember? Well, in most standard setups, no. Your reminder is literally just gone. And that perfectly illustrates the fatal flaw of what we call conversational promises versus the rock-solid reliability of real system-level cron jobs. You see, most chat-based AI agents just hold your reminder in their short-term session memory. They basically just set an in-memory timer. It's essentially a promise that only lasts as long as the application is actually running. If the app restarts, boom, the memory is wiped and the timer is destroyed. But the solution we're looking at today abandons that fragile approach entirely. Instead of trusting the AI's frankly terrible memory, it wires your chat message directly into the server's operating system using real cron jobs. This means your reminders actually survive restarts and execute with total deterministic precision.
All right, moving on to Section 1, the OpenClaw gateway context.
Now, to really appreciate how this solution is engineered, we need to quickly ground ourselves in the ecosystem we're working with here. And the foundation is OpenClaw. Think of OpenClaw as a powerful self-hosted gateway. It acts as the ultimate bridge, allowing power users and developers to self-host their AI agents, like coding assistants or personal bots, and connect them directly to everyday messaging apps. While it does support platforms like Discord and Slack, today we're zeroing in on its integration with QQ via the official qqbot API. Because OpenClaw runs as an always-on process on your own hardware, it means you actually own the data and control the gateway completely.
Let's get into Section 2, introducing qqbot-remind-absolute.
This brings us to the core fix for that AI memory issue, built natively right into this OpenClaw environment. There's a quote from the source article that absolutely nails the paradigm shift we're looking at today. It says, "Cron jobs persist across restarts. In-memory timers don't." It's so simple, but so true. The skill we're analyzing, qqbot-remind-absolute, completely bypasses the AI's conversational memory for scheduling. When you ask it to remember something, it doesn't just say, "Okay," and start some fragile internal stopwatch. Instead, it talks directly to the OpenClaw cron engine, which is the underlying task scheduler, and registers a permanent OS-level job. No polling, and absolutely no conversational promises.
And I want to point out, this isn't just some theoretical experiment. With 97 stars on GitHub, this highly specific skill proves there's a serious community of developers out there who rely on QQbot and OpenClaw for their critical daily workflows. They've experienced that exact footgun of conversational timers dropping their important reminders, and they've actively adopted this robust infrastructure-level fix.
Which brings us to Section 3, parsing time locally.
Okay, when you send a message to your bot, you obviously don't want to type in computer code, right? You want to use natural language. Well, this skill handles common time expressions seamlessly. You can type in standard times like 21:30, or use natural language phrases that translate to tonight at 11, tomorrow morning at 8, or even recurring stuff like weekdays at 9. But the real magic here is how this is actually processed. Instead of calling out to a massive large language model to figure out what tomorrow morning means, which, let's be honest, wastes time and processing power, a dedicated local script called schedule-reminder.py uses a deterministic parser to instantly translate these expressions into exact system times.
The benefits of this local parsing approach are just massive. First off, 0 LLM tokens are wasted. You aren't paying OpenAI or whoever else just to figure out what time it is. Second, you get ultra-low latency. The response is virtually instantaneous. And third, it's highly reliable and deterministic. By parsing locally, you completely dodge the hallucination risks of an AI just guessing the wrong time or date. It's a great reminder that sometimes a traditional, well-written script is just far superior to relying on an AI's conversational interpretation.
All right, Section 4, Setup and Time Zone Rules. Getting this right requires some strict attention to detail, so let's walk through it. The setup requires a very specific flow. Now, the most critical step is actually the first one. You absolutely must start the qqbot process manually first. Why? Well, because the setup script contains interactive prompts. If you just try to launch OpenClaw in the background in headless mode right out of the gate, those interactive prompts are going to invisibly block the entire process from starting up. So you start it manually, clear those prompts, clone the skill repository into your OpenClaw directory, and then, finally, set your time zone.
And speaking of the time zone, you literally cannot skip this step. On your very first use, the skill strictly requires an explicit per-user time zone setup before it will accept any reminder commands whatsoever. You have to send a specific chat command to the bot, which translates to set time zone Asia/Shanghai. If you try to set a reminder before doing this, the bot will just block you and demand your time zone.
Here's a quick pro tip on why this strict requirement is actually a brilliant design choice. It uses IANA time zones. Think Asia/Shanghai or America/New York, rather than simple UTC offsets like UTC+8. This prevents your recurring jobs from drifting. If you live in a region that observes daylight saving time, a simple UTC offset will suddenly be an hour off twice a year. By forcing a proper IANA time zone, the underlying cron engine automatically adjusts for those daylight saving changes. That means your 8 a.m. reminder is always going to fire at 8 a.m. on your actual wall clock.
Once you're perfectly configured, managing your reminders is incredibly easy. You get full CRUD capability, create, read, update, delete, over your system cron jobs, entirely through natural chat messages in QQ. It's so cool. One message sets a job. You can create one-shot reminders for meetings, set up recurring daily habits like drinking water, ask the bot to list out all your active reminders, and precisely delete specific ones by their ID. You are quite literally programming your server's task scheduler just by texting your bot.
Let's wrap things up with Section 5, Building Persistent AI Assistants.
Let's look at the broader picture here. As robust as this setup is, there are a few operational watchouts you really need to keep in mind. First and foremost, while the cron job will always fire on the OpenClaw server exactly on time, your qqbot channel process actually has to be online to deliver that message to your phone. If the bot is down, the cron job fires, but the message fails silently. Second, be aware that user time zones are stored locally in a specific JSON file right within the skill directory. You definitely need to make sure you don't accidentally overwrite this file when updating the software. And finally, while the local parser is fantastic, it doesn't support complex edge cases like lunar calendars just yet.
Upgrading from an AI's conversational memory to actual hard-coded system infrastructure is really the only way to build a personal assistant you can truly trust. Relying on an LLM to hold a timer in its memory is a massive footgun just waiting to go off the second your server needs a quick reboot. So as you look at your own workflows and the bots you interact with every single day, ask yourself, are your bots' reminders truly persistent, or is your AI assistant just making promises it can't actually keep? Thanks for joining me on this explainer, and I will catch you on the next one.